today is going to run. There we go. For those of you in the chat, if you would please leave a comment, that'd be wonderful. Let me fill you guys in. Anyway, first and foremost, I am going to be assigning you something to do off of a worksheet. I'm going to be posting that on Google Classroom. That worksheet is going to be based on stuff that we do today in the second half of the class period. I'm going to be posting this PDF for us to work off of a few examples together in class, and then I'm going to be assigning you some problems to do on your own in regards to exponential word problems. So excited. But first, the first part of this class period, I am going to be taking some time to introduce to you certain aspects of the project. There is going to be a project that I am going to assign you probably before the end of this week. And when I assign this project, I will have gone through, over the course of the next few class periods, various aspects that I need you to be aware of. Now, I'm going to be taking my time with these aspects mainly because they involve some research on your part. And I need to take the time showing you how to go about doing that research, because not a lot of you have that knowledge of like, okay, how do I traverse the bank website? How do I traverse a site like realtor.com or something along those lines? And what sections do I go to in order to find the proper information that is needed for the project? It's going to be nice, but we'll get there. So only 4 people in the chat. That's weird. How many people are virtual in this class? Is that your guess? It says 8. So you went from 13 to 3 or 4. Anyway, I got you. Okay. So this project that you're going to do for me, this project is going to be based on exponentials and logarithms, in which you are going to be faced with a scenario where you have to research banks, cars, and houses. Now, I've explained a little bit of this before, but I wanted to go into greater detail today. Today, I'm going to be focusing in on the banks. In terms of the cars and the houses, everyone will be doing a different car and a different house. The project, yes, will count as a major. Now, mind you, I'm not assigning it today. I am going to be assigning it by the end of this week. I'm going to be taking the time to explain various aspects of it. Now, in order to ensure that you get different cars and different houses, I do have a system of selecting the cars and houses. But in terms of the banks, there are a limited number of banks in this area. But I am going to have you ultimately research 3 different banks. And then you choose one of those banks to move forward with your calculations. Today, I am going to be showing you some aspects of TD Bank. I have in the past. I'm going to go again. But for your project, you can't use TD Bank. That's up to you. Now, for the banks, there is going to be overlap and repeats, of course, but you ultimately will have to research 3 banks. You'll see. So, in terms of me explaining this project to you, I'm going to be very precise with my language here. I'm not going to require you to write down what I explain about the banks, but I am going to strongly encourage you, hey, if I'm explaining something about the bank website that you're like, oh crap, I didn't know that, then perhaps that's something that you need to write down for when you actually do your research. But we'll get there. So let's talk about the TD Bank website. The first part of the project is you are set with this scenario of inheriting $10,000. You've inherited $10,000 and you want to be responsible with your money. So you take that $10,000 and you invest it in the bank. Yes. Give her a chance to get back. Yeah. Actually, let me check something real quick. Every now and then I check the Dow Jones. Dow Jones is up 120 today. About Texas? What do you mean? That's their individual choice to do that. Different states have different rates of infection. That's not for me to say. I'm a math teacher. I'm not a medical expert. And anyone who professes to be one, you know. True, absolutely. Of course I have opinions on things, but I'm a math teacher. Back to this. Now. Wow, that's on your mind? Okay. Anyway. Now, in terms of the TD Bank website, as I've shown you in the past, TD Bank doesn't have the best information available. The first part of this project, and you just came back, I'm going to explain the first part of the project that I am going to be assigning before the end of this week. Who's on the phone? Who just got in trouble? You're in trouble? Mr. Mark is here. Mm-hmm. Yes. Okay, before the end of the day. Okay, bye-bye. It was you.
What?
Before the end of the day, athletic office, they have paperwork for you to pick up. Yeah, I know. Anyway, back to this. So TD Bank, as I said, doesn't have the best in terms of percentages and rates that they give you. You put your money into TD Bank, and once a month, they present you with a little bit of interest. By the way, do you know why banks give you interest? More than that. A little bit more than that. Yeah, it's not just to keep you in the bank. They do want you to stay in the bank, but why? Kind of. Loans are a big part of it, but they take your money and they invest it for themselves. Now, if they incur losses, they guarantee that your money will still be there. You know what I'm saying? They guarantee it. You put in $10,000, and if the bank has like a really bad month and they end up losing like a lot of money, they still have to promise that your $10,000 will be available to you, because that's what banks do. They guarantee your money, you know? But they use your money to make money for themselves and to compensate you. Here's your nickel. I'm not even kidding. So you go to the TD Bank website and you got to look up a savings account. I'm not looking up checking accounts because checking accounts don't earn interest typically. Some of them do, but not all of them. Savings accounts are where you need to earn the interest. So you go to your bank's website, the three that you're going to be researching, and you need to find certain pieces of information. So I go to products and I go to savings. Again, each bank website is set up differently. I am not asking you to create an account. Just to be very clear about this. I am not asking you to create an account on a bank website. You are simply trying to find the information. It is a fact-finding mission. You need to find a few different pieces of information, but more importantly, you need to find the rate of growth. The rate of growth of how much interest you would potentially be earning. Your interest rate is one of the first things that you need to find in regards to these accounts. Also, you have to be sure that you qualify. Now, I've said it a couple times today. In this project, how much money are you being given in an imaginary sense? I said it a couple times. No, 10. I'm giving you $10,000. Imaginary money. Yay, we're rich. Whatever. So I scroll down a little bit on this page because I'm not actually opening up an account. And I find these three accounts. First thing that I need you to recognize. APY. You're going to see this a lot. APY stands for annual percent yield. Annual percent yield. Good question. APR is typically something that you would pay in interest when paying off, let's say, a car. You know what I'm saying? Because usually you see those in like car commercials. APY is how much the bank would actually pay you. So there's the difference there. There's interest being paid in one direction or the other. For the car payments, APR, you would have to pay interest on top of what you owe. And then APY for the banks, that's the interest that they would give you.
Why would the bank make it to the 0.15%? You have that 250,000.
Yeah. Well, these are the bank's individual choices. Let me explain what he just asked, actually, because this is actually a huge fundamental issue with banks. See, the thing is, there are three major bank accounts, savings accounts that you see right here, and clearly this one gives you the best interest rate. Clearly, right? But you can't qualify for this interest rate unless you have a minimum of $250,000. True? No, I know, but you only have 10. Now, the question that he's asking is like, well, they're not going to have like $250,000. Like, if you have that much money, you're going to be getting paid more interest because it's a higher rate. But there's going to be less people who actually qualify for this particular type of account that have $250,000 in cash. See, here's the thing. I know a lot of people who, now I'm going to be very clear with my wording, precise wording. I know a lot of people who have a net worth. No, net worth is like the objects that you own and their worth. For example, your house. If your parents own the house, how much have they paid off on the mortgage? How much they've actually paid off on the mortgage, that's the amount that they have in the house, and that's the worth that they have. You know what I'm saying? In terms of your cars, how much are the cars worth? In terms of the objects that you have, how much are the objects worth? You don't just have your money in a savings account. You also have it, let's say, in the stock market, in a mutual fund, in a retirement fund. Grand total. So in order to qualify for this is not your net worth. You actually have to have this liquid cash on hand, which not a lot of people do. So you don't qualify for that. You also don't qualify for this. That's a conversation for another day. I do have information on that. $430 a year? What do you mean? Oh, 430,000. Okay. I do, like I said, I do have statistics on that, but that's for another day, as I told him. But back to this. You don't qualify for this one either because you need $50,000 minimum, so you qualify for this. Now let me be very clear about this. This is not 2%. This is not 2%. This is 0.02%. This is less than 0.1%. It's insanely bad. You know what I'm saying?
So then that's just 1%.
No, it's not. Yeah. Second? We'll come back to it. Okay. What's up? Oh, yeah, Rocco. Oh, the 0.10%. Well, the thing is, in the formula, you eventually have to put in the rate, right? And if it's 2%, you would put in 0.02. But this is not 0.02. This is not 2%. This is 0.0002 that you would actually put into the formula. Twice to the left, or divide by 100. Dividing by 100 is a lot easier. Think about it. 50%. What's 50% as a decimal? 0.5 divided by 100. 50 divided by 100 is 0.5. Yeah. But if you divide it by 100, that's the number that you would actually put in. Now, the thing is, in the scenario that you have for the bank, you have $10,000. You get a bank account that's a certain rate, and I got this rate right here. Mind you, the different banks that you research, you have to get banks with different rates, obviously. Can't just do the same calculation over and over again. But you need to find N. You need to find the number of times compounded per year. Now, I'm going to be very blunt with you. I'm going to be very, very blunt with you. When banks calculate their interest, yes, they use compounding to figure it out. However, they do not advertise how often they compound. They don't advertise that to the general public. You know why? Because they believe that the general public are morons. They do. They know that the general public, when they look at that compound interest formula, which we're going to write down into our notes again in a little bit, but when you have that compound interest formula, most people are going to be like, I don't know what the heck that means. So if a bank's like, hey, we compound monthly, you're going to be like, okay, what does that mean? The average person has no idea. So banks don't advertise that. So I went on a little fact-finding mission. Now, most of the time you could Google this. You could Google, okay, TD Bank, how often do they compound per month? And you can eventually find a response where you get that information. And guess what? You're going to need that information for this project. You will. For this project, I require evidence. And the evidence that I require will come in the form of screenshots. So for example, right here, boom, it's the TD Bank website, simple savings, 0.02%. Screenshot this and include it in your project. There's your evidence for one bank. Of course, you have to find your evidence for 3 banks. But of course, you can't use TD Bank because I'm showing you TD Bank. Oh yeah, that was the part that you missed out on. You can't use TD Bank for your project because I'm explaining TD Bank. Potentially, but you're going to be doing different calculations, of course. And not everyone's going to use the exact same 3 banks. Some people might, but that's what happens. But for the car and the house, I have a system where I guarantee you have different houses and different cars. Again? Nope. They do not have to be in this local area. Sure. You can keep saying states. I keep saying sure. Now, in terms of compounding, if you look up and down this page, there's nothing. If you view account details, there's nothing. You can't find the number of times compounded per year. It's not there. Where is this information found? Well, again, you can Google it. You can Google it because a lot of the time when you do a Google search for this kind of stuff, you will find it. And you will find the number of times compounded per year. Has anyone ever opened up a savings account in real life? Did you get a ton of paperwork when you opened up that account? Did you ever read that paperwork? No one ever has. No one, not even people at the bank have read it. Because the thing is, I had to go to this. This is a personal deposit account agreement that you get when you opened up a savings account at TD Bank. This is a 36-page document that they give you. Say, well, all the information's in there. So if you ever have a problem with TD Bank, they're going to be like, did you read the agreement? And you're going to be like, nope. See, the thing is, I didn't actually go through this 36-page agreement. I did not. I did a keyword search. You guys know how to do keyword searches? Control F. Check this out. If you Control F and then go compound, you find it. And this is what I would screenshot if I were doing TD Bank on the project, which you can't because you're not allowed to. But I found the bank compounds interest monthly. I found it. It's on page 17 of a 36-page document. It's the only time. Look at the word compound. Look how many times it actually shows up in this document. 3 times total. They're not hiding that information, but at the same time, they're not advertising that information. And they're not advertising it because they think the general public are morons. So, if I compound monthly, how many times is that a year? Just 12. Yeah, 12. So N is equal to 12 for TD Bank. Most banks compound monthly, but you need to find the evidence. Screenshot. Some banks compound daily. Some banks compound quarterly. It depends. Some banks just compound annually. You need to find the evidence. Find me the evidence. Google search it. Keyword search it. Do what you got to do to find me that evidence, but you can't use TD Bank. So what I'm going to do, I'm going to go over here because I want to calculate something for TD Bank. Now, we've written down this formula before, and it's up to you whether or not you want to write down this information again. But I'm going to do a couple different calculations here. We wrote this down last time. This is the fancy compound interest formula. This is the formula that banks use when calculating compound interest, to calculate how much money they are actually going to give you in regards to interest. So let's see. TD Bank compounds monthly. They compound monthly. So I'm going to put a n equals 12 there. There we go. I have $10,000 to start with. So there's my $10,000. Where is this thing? There we go. Good. Ah, my glasses. See, this is what happens when my glasses break. They keep falling off my face. And your rate is 0.02%, which I would put in as 0.0002. This is the information that I would need. Give me a two-digit number. Sure. How much money after 24 years? How much money after 24 years? So the idea is that your parents, let's say, get $10,000. They go to TD Bank. They put the money into a savings account for you at 0.02% interest, and they're like, this is going to be a good thing. We compound monthly. We're going to leave it there for 24 years. Hopefully by 24 years, they will have graduated high school and college and whatever. After 24 years, you would think that you're going to have a good chunk of change. Let's see. And I'm going to show you how you would type this into the calculator. You got to make sure that this stuff is typed in correctly. But I put that stuff into my calculator, and I'll do that in a moment. I just want to leave that on the screen so people have an opportunity to copy that down. Put that to the top, actually. But you got to make sure you put that interest rate in correctly. I'm going to show you the difference between 2% and 0.02%. I'm going to show you that difference. The exponent needs to be calculated separately, or you put its own set of parentheses around it. We're leaving it there for 24 years. Let's go to my calculator. 10,000 times 1 plus 0.0002 divided by 12. Notice, literally, I just type it in like that with parentheses. That'll work. If you type it in like that with parentheses, your calculator will get this done correctly. It will. Parentheses, 12 times, I didn't put the 12 in, 12 times 24. There we go. $10,000 left in TD Bank for 24 years. $10,048. They round down, but if you round it up, that's up to you. I'm not going to fault you for that. And 11 cents. Yes, Kelsey, I just saw your comment. I'll do that in a moment. I just want people to have the opportunity to copy down that portion of it. You need to diversify. You need to diversify. If you leave your money in a regular bank savings account, you're going to earn next to nothing. After 24 years, you have an extra $48.11. $48.11. That'll buy you a couple of pizzas. Maybe, depending on the toppings. I'm going to leave this up here for a moment because they asked, Kelsey asked to see that. But now, again, I'm going to do something else with this. The question is this. Okay, do you know what a decent price is for a home in this area? 270,000? Yeah, give or take. I'd say that's about average. I would say 200,000 will get you a pretty decent house. Small house. But 200,000 will get you a good house. Well, depends on where in Texas, though. Well, if you live in the middle of nowhere, it depends on like how much land you have at that point. You know what I'm saying? No, I'm just saying, because depending on where you live, because some houses obviously cost a bit more. If you own a lot of farmland in Texas and you have like neighbors that are like miles and miles away, you might have a lot of money, but you also might not. It's possible. I don't want to stereotype. But the question becomes this. Let's just round it to 200,000 in this area. You need $200,000 to buy a house. You have $10,000. How long? Here comes the question that we are going to answer. How long would it take for this $10,000 to turn into $200,000? We're going to figure that out. We're going to figure that out right now. We're going to figure out how many years it'll take. So, we will. The question that he just asked, just for the sake of people in the chat and in the classroom, he asked the question, do we have to use log? The answer is yes. Because the question was, how long? How long implies that we are going to be solving for an exponent. And if we're solving for an exponent, you're going to have to use a logarithm. So, the question is this. How long until my 200, no, not 200, my 10,000, there we go. How long until my $10,000 reaches $200,000? This is something you will have to do on the project with different values. I say different values because you're going to have different interest rates. It's going to be a different amount that you're going to be reaching. But you're going to have to figure out how long it'll take, and you're going to have to show me the work. So it's similar information, except this is the setup to the problem. There we go. I'm going to read that, make it a little bit more clear. It's 200,000 equals 10,000 parentheses 1 plus 0.0002 divided by 12 in the parentheses. But then this exponent up here, where my pen is pointing, that exponent is 12t. It's 12t. Because the t is the number of years it will take. And as he just said before, yes, we're going to eventually use logarithms. We will eventually have to use logarithms because we are solving for an exponent. So, how do we go about doing that? Well, first, I'm going to have to divide both sides by 10,000. In order to get to that exponent step, I first need to take care of this multiplication step. I'm going to divide both sides by 10,000. That's going to leave me with 20 equals the parentheses, which have not changed, and the exponent, which has not changed. Now is the time for logarithms. Logarithms allow you to get the exponent by itself. Logarithms are only needed when you need to solve for an exponent. So I'm going to convert to logarithms. Now, I'm going to convert to logarithms, but I'm going to be very precise with how I write this, because obviously you do have a log-based formula in your calculator, but you need to make sure everything's going into the proper location. The base on that exponential is going to be the same base that is on your logarithm. It's a subscript. The base that is on your exponential, which is the 1 plus 0.0002 over 12, is going to be the same base that is on your logarithm. Using logarithms allows you to get the exponent by itself. So when I write this in logarithms, the exponent is by itself. The entire 12t is the exponent. And the 20 is the only thing left over. In a moment, I'm going to go to my calculator. In a moment. Just giving people the opportunity to write that down, because I see several people are. Thank you for that. What's on the left side of the problem, I'm going to have the calculator do. The left side of the problem, the calculator is going to get that crap done for me. But we have to get there. We do have to get there. So I'm going to go to my calculator. I'm going to hit math. I'm going to go to option A, which is log base. And I'm going to type in exactly as I see it. 1 plus 0.0002 divided by 12. There is my base. 20 goes in the parentheses. And I get that number. Now, that number is not my answer. That number is not my answer. What does that number equal? Well, that's what the number is, but what does it equal? It equals 12t. The left side of the problem calculated to become that number. Yes. Ultimately, it's just dividing by 12 to get the final answer. Because again, that's what the exponent is. I was able to use the calculator to get that thing done, to get the left side of the problem calculated, to get the value of that logarithm. And then ultimately, I just have to divide by 12 to get that answer. You walk into TD Bank. You have $10,000. You get a savings account and you say, you know what? I'm not going to take my money out until I reach 200,000 because that's enough. That's enough to buy a house. It would take you almost 15,000 years. It would take you almost 15,000 years. I don't know if banks will last that long. Well, what country in this world has lasted, over 1,000 years? Britain. Actually, you think about England. The first king was William the Conqueror. That was in 1079 or something like that. I don't know. It's rare though, right? Hold on. First king of England was that's Britain. See, these aren't English kings. There we go. William the Conqueror. Well, I know, but I'm just saying Greece, the way it exists today, is not the same way it existed 1,000 years ago. I'm just saying. Anyway, but that's the answer to this question. Ultimately, you're going to have to do these calculations for the bank account. You are going to be researching 3 different banks. And then ultimately, you're going to be doing all of those calculations with one of those banks. because I need you to do the research on the banks for me. This is actually a project where I'm having you do financial advice for me. So we'll figure this out. I'm going to pass these out. This is what we're going to be working on for the remainder of this class period. Now, again, for the project, I'm not assigning the project until later this week. In the next few class periods, I am going to be going over the housing part and the car part of the project with you. These are very important parts that are all recorded on video that you can go back and check anytime you want. But you need to have this information handy for when you actually do the project, which you're going to be starting, hopefully, by the end of this week. I got 4 right there for the 4 of you there. I got 4 right here for the 4 of you there. And I got 3 right here for the 3 here. There we go. For those of you in the chat, I'm going to be posting the PDF of this worksheet in a moment. Today's a B-Day. That's why you're in my class. You have other people do it for you?
Yeah, I just follow Jess around every day.
Nice. Let's see. Period 3B. I'm going to be adding from the Google Drive. Where is it? Where are you? There you are. PDF for today. Post. Chapow. There we go. So those of you in the chat, you know have this. Here's what I want to do. For homework, I am assigning you some problems off of this PDF. For homework, I am assigning you some problems off of this PDF. I know which problems I'm going to be assigning. I just obviously haven't assigned it yet in Google Classroom. But what I would like to do, just to start this off, is I would like to do a few problems together. Depending on what the question is asking, you may have to perform a different task. Let me show you what I mean. So if I go to this worksheet, and again, for those of you here, you have the physical copy, so you don't have to strain at the board. For those of you online, you have the PDF, so you don't have to strain at this camera. But if I look at this PDF, I'm looking at number 2. I'm looking at number 2. And we read, in 1985, there were 285 cell phone subscribers in the small town of Centerville. The number of subscribers increased by 75% per year after 1985. How many cell phone subscribers were there in Centerville in 1994? First of all, I ask you the following question. Is this problem a growth, a decay, or a compound interest problem? It's a growth. And because it is a growth, you are going to be using the following formula. You have to identify, based on the context of the problem, whether it's a growth, a decay, or a compound interest. Now, if it's a compound interest, now typically they'll say the word compounded or a compound interest. For example, if you look back at number 9, number 9 has compound interest problems, and they literally use the word compounded. But again, that's neither here nor there. Let's talk about this problem, number 2, cell phone subscribers. What are we actually solving for? What letter in this formula do we actually need? It's a bit hard to kind of wrap our heads around. Let's figure out what we have. We will be. Say again? Which he said was the variable y, which is, yeah, the ultimate in 1994. Do we have the value for A? Yeah, because A is what? The initial value. Do we have the value for R? Yes, and make sure you put it in as 0.75. You have to convert it before you put it into the formula. Make sure it is converted. Can you post a picture of the packet filled in with what we went over for reference when completing the list? Kelsey, I'm reading your question. Could you email that to me? Clarify that a little bit. I'm trying to figure out if you're referring to the project or not, but make sure, Kelsey, send me an email with your question and I can think about it a little bit later and get back to you. I'm sorry, go ahead. What is 9? Ah, yes. X is equal to 9. X is equal to 9. Now, X is time. Time measured in the same time unit that rate is measured in. Oh, sorry, I just read. Yeah. Anyway, yeah, and the time, well, it starts in 1985, and you're going all the way to 1994. So yeah, it would be 9. There's a little bit of a twist here. There is a little bit of a twist here after we fill in the proper information. When you do this calculation, 285 parentheses 1 plus 0.75 to the 9th power, I literally type it in exactly as that. When I actually calculate it, look what I get. 43,871.99. What's wrong with that? It is a lot. No, that's not what's wrong with it. What's wrong with that? There's my calculation right there at the bottom. What's wrong with it is you can't have a fraction of a person. You can't have a fraction of a person. This is a word problem. There is context. If this were money, yeah, totally. You can go 2 decimals on money. If this were like the weight of something or, I don't know, something along the, I can't even think, like the weight or the height of something, then yeah, you could totally go decimals. But these are people. You can round up or you can round down. That's up to you. But I'm going to round up. 43,872 cell phone subs. You can't have a fraction of a person. So I'm going to round it to a whole number based on the context of the problem. Let's talk about number 3. I am going to give you a couple problems to try on your own, but let's talk about number 3. Bacteria. Bacteria can multiply at an alarming rate when each bacteria splits into 2 new cells, thus doubling. If we start with only 1 bacteria, which can double every hour, how many bacteria will we have by the end of 1 day? Man, I wish word problems related to stuff that happened in real life. Well, kind of, but let me talk about this. That's why I haven't written anything down yet. Doubling, and we have written this into our notes before, means B, not R, but B is equal to 2. What the heck is B? Remember, it was Y equals A times B to the X power. That B was 1 plus R. Technically, when you are doubling something, it means that your rate is 100%. And in fact, 100%, if you converted it to the decimal, would be a 1. 1 plus 1 would give you 2. But that's what doubling really means. Y equals 1 parentheses 2 to what power? Hold on. How many bacteria will we have at the end of 1 day? 1 day! So what do I put up there? No. What do I put there? It's at the end of 1 day. It's the time unit X. Say again? Why 24? Well, it's an hour per day, but why are you measuring the day in hours? More specifically, the rate set every hour. Not just it, but the rate. The rate is measured every hour. Thus, your time unit needs to also be measured in hours. That's the trade-off. The rate and the time unit have to be the same time. Ultimately, if you do this calculation, 16,777,216 bacteria cells after 1 day. Wash your hands.
How many died?
It's a good question. I don't know.
777?
Yes. Pops up right in the middle, huh? Now, what you're actually referring to, you're talking about like, how many people would potentially die or something along those lines. Obviously, it seems kind of morbid to think about that, but the people who actually study, let's say, like infectious diseases, yes, they have to be looking at replication rate of the virus, but they also have to be taking into account, well, if somebody dies, let's say in isolation, the bacteria should be dying with them. You know what I'm saying? So it's a weird kind of trade-off where you also have to take into account not only replication rate, but death rate and things of that nature. The science that has gone into this pandemic is nuts. But anyway, I want you to try a couple problems. I want you to try a couple problems to kind of wrap up today. Now, I am telling you that I am assigning you a homework on this, but let's see what you can do with this. I want you to try numbers 5 and 6. Let's try numbers 5 and 6. I want you to read carefully. See what you can do with numbers 5 and 6. And we'll reconvene in a few minutes because 5 and 6 should not take you that long. Mine? Sure.
Said 5 and 6.
Yes. Oh, yeah. See, ultimately, when you guys do the research on your cars, you're going to be putting this whole thing together. Cars and houses, I should say. Where if you look up a car listing, you have the current value of the car, how much it's being sold for. Yeah? All right. Let me ask my one question. I'll let you guys think about. Do you know what it's called when you have the initial value of the car? There's a special term for the initial value of the car. We'll talk about it. Say again? The initial value, but there's a special term for it. Of a car.
MSRP.
There he is. Yeah. Yeah, they want the value of the land, the resulting value of the land.
Just saw that.
Yeah. See, the thing is, every question is going to ask you something slightly different. Some of them will be asking for the resulting value. Some of them may be asking, well, how long until it reaches this? Or some questions, and eventually you'll see this with the project, some questions will eventually be saying, what's the rate of increase or decrease? And depending on what you have to solve for, you have to do something slightly different. But yeah, he answered the question about the initial value of the car. Do you know what MSRP stands for? You know what MSRP stands for?
I don't know.
Gotcha. No, but you're absolutely, it's MSRP, manufacturer's suggested retail price. Yeah, and those are historically known. Those are historically known. So whatever car you look up, you'll be able to find an MSRP on the car. You know, which is nice. So you'll have the initial value, and you'll have the resulting value, and you know how old the car is. No.
Unless it's like, you know, like, for example, the Toyota Corolla came with a new generation of cars.
Sure.
Try to get that one because the new generation. Otherwise, if it's the same generation, they'll be on.
So to speak, yeah, I would agree with that.
You know what I mean? Like, see, they go with the new Camaro, the new generation, like the 6-Jam. You can get a new 6-Jam, but if there's still 6-Jam Camaro,
Just wait a couple years till you get it.
yeah.
You know? Yeah. What's up?
This is 2.5.
Remember, divide by 100. You take the rate, divide it by 100. You type it in, actually see it visually. Whenever you type the rate in, it's going to be smaller than the percentage. Yeah. So let's talk about this. Number 5. The population of Winnemucca, whatever, Nevada, can be modeled by that equation. Cool. They don't use X and Y, they use P and T. All right. But T is the number of years since 1990. What was the population in 1990? What was it? Huh?
It was 200 million.
What?
6,100.
Yeah, you guys said that. He said 200 million.
Yeah, wait, hold up. Oh, my bad. I thought you meant, no.
Okay. But yeah, it's 6191. Now,
Oh,
no, she's just teasing you. Now, 6191, there's two ways of doing that. Two ways of determining the population in 1990. First and foremost, the value of A is 6191. Here's a different way. If you're in the year 1990, what do you plug in for T? No. They are not asking for T. I agree with that. But in the year 1990, what value do you put in for T? And it's not 1, though. You do put in a 0. And if you actually put a 0 in for T, it will calculate to become 6191. It will. By what percent did the population increase each year? 0.04 or 4%, yes. Because it's a percent. So if you leave it as 0.04, that's the decimal. They wanted to know by what percent it actually increased. So you would have to convert it back. Now, I'm going to show you this on the computer. I have assigned you the homework that I want you to do. And that homework is based on this worksheet. This worksheet has been posted directly to your Google Classroom once again. And these are the problems that I would like you to do. Mr. Markey, you didn't go over number 6. Oh, man, I guess I ran out of time. I didn't get to go over number 6. No one's going to say it? Why? I didn't go over number 6. Why did I do it on purpose? Nope. It's the first problem from your homework. So, 6, 7, 8, 9, and 12. I want that. Now, it says Tuesday. I got to change that to Wednesday. I'll change that right now. Hold on. Let me change that right now. But if you haven't left a comment in the chat, please make sure that you do so. The bell's going to ring in about 20 seconds. I got to change that. It is due Wednesday, not Tuesday. There we go. Wednesday, March 10th. Save. There we go. All right. I'm going to sign off.